Welcome back students, 12th standard. You are in a class now which is of real importance for your life. Be serious, sincere and be consistent. Means start working right from day one. If you really want to grasp the subject, then you will have to study every day for every subject. I will suggest one thing, you study for 10 minutes a day per subject at home. That is self-study. I am not talking about college, I am not talking about classes. Find 1 hour and study for every subject for 10 minutes. See, whatever we complete in a day in classes or in school, whatever is completed in one lecture can be revised in 10 minutes. The basic thing is you have to be consistent. It is not like 10th standard that you slog in the last month and then you get 80-90% marks. Here the syllabus is too vast. Syllabus is really vast and now it is new syllabus. They have added certain things to the previous syllabus. Few chapters in the old syllabus were in 11th standard. They have brought them up to 12th standard. So you have to be really sincere, pay attention when you are in the class, when you are attending these videos. And I will suggest one thing. When you use your notebook, on the last page, start writing all the formulae chapter wise. Because whenever we start solving the numericals, it becomes a problem. What formula is to be used? And how it is to be utilized, how it is to be applied to the given sum. So first you have to know the formula and your paper consists of compulsory 16 mark numericals. Out of 70, if there are 16 marks given to the numerical, then you will have to attempt them, otherwise you are writing a paper worth 54 marks. And in the theory part, there are chances that you lose marks because whenever you are writing a theory question, there might be one word missing from your answer and half mark may be deducted. Or in certain cases where there are derivations, if you don't draw the diagram properly, the half mark which is reserved, half or 1 mark depending upon the diagram, those marks can be deducted very easily. At the same time, you have to practice the diagrams from the textbook. See, if you on an average see the question paper, there are 4 minimum diagrams which are asked or which you have to draw in the derivation or draw a neat label diagram type of question. So all the diagrams practice very well. Improve your calculation ability. Improve your log calculations. Start using the log table now only because many of you in 11th standard have not used log table properly. So that practice you have to do. Now I am starting in physics with chapter 1 whose name is Rotational Dynamics. In the previous syllabus, there is no change actually in this part. Rotational dynamics is combination of 2 chapters in the previous syllabus. One is circular motion and second is rotational motion. So first we are going to deal with the quantities which are required in studying circular and rotational motion. I am going to start with, I'll write few words here and then explain what they mean. The first word is circular motion. Second word is radius vector. Third word, angular displacement. Fourth word is angular velocity. Fifth word is angular acceleration. Still few words are there, but as I will need the space on this side for the discussion of these terms used in circular and rotational motion, I will first discuss these 5 and then we will go to the next part. The first word everyone can easily understand. It is represented in short form as capital CM. This is circular motion. Now, word itself means that if any particle is moving along the circumference of a circle, then the particle is performing circular motion, or in general you can define it as motion of a particle along the circumference of a circle is called as circular motion. Nobody is going to ask you these definitions in the exam, but you have to know the meaning of these words, formulae for them. Then you will have to know what are the SI units of certain quantities and the dimensions. I will be giving you some basic formulae also, because those are needed for the derivations which we are going to carry out later on. Now assume that O is the center of the circle and particle is at point A. Just an assumption. This particle is performing circular motion along the circumference of a circle whose radius is R. The radius of the circle is R. Now I am coming to the second definition, radius vector. Radius everyone can understand. It is the constant distance from the center of the circle. What do you mean by a vector? Vector has direction. So radius vector is a vector drawn from where to where? From the center of the circle to the position of the particle on the circumference. See the direction of this vector. It is outwards, means it is directed away from the center. So such a vector which is drawn from the center of the circle to the instantaneous position of the particle is called as radius vector. Now assume that this particle after some time reaches point B. Particle is moving in anti-clockwise sense, you can consider it in clockwise sense also. This is opposite to the arms of a clock. It is just for convenience, it is not particularly defined for anti-clockwise or clockwise. So the particle moves from point A to point B. Now what is the radius vector? Now the radius vector is OB bar. The radius vector is denoted by R bar on top of it, indicating that it is a vector, it has direction. In the process, this radius vector has traced certain angle. I will call this angle as delta theta. Generally, we will be using the notation theta for it. So this is the angle traced by the radius vector in any time, say 1 second, 2 seconds, etc. This angular measurement delta theta is called as angular displacement. How you define linear displacement? Linear displacement is straight line distance between initial and final position of the particle. So this is linear displacement. In a similar manner, the angle traced by the radius vector in given time is called as angular displacement. How you measure angle? Angle is measured, SI unit of angle, all of us know it is radian. If it is a plane angle, that is angle drawn in a plane, then it is measured in radian. It is not, degree is not a SI unit of angle. What are the dimensions? I am writing delta theta here. So, we are talking about angular displacement. Its dimensions delta theta bar are m0, L0, T0. In short, you can say angular displacement does not have any dimensions. Now, why this bar is drawn? Bar indicates a vector. So, if the angular displacement is small, then it is a vector quantity. I will write type of quantity here. It is a vector. So, vector you must specify the direction. So, vector direction given by right hand thumb rule. Can you recall right hand thumb rule? Curl your fingers of right hand. If the particle is moving in the direction of the curled fingers, the outstretched thumb gives the direction of angular displacement. So, if I consider anti-clockwise rotation, I will have to put my fingers in curled manner like this. So, my thumb is coming outwards, or I can show you this in the horizontal circle. If the particle is moving this way, anti-clockwise direction, then I will have to show angular displacement in the upward direction. So, this will be delta theta bar. The length of this vector will be proportional to the magnitude or to the angle actually, but its direction will be given in the upward or downward direction, here out of the plane or into the plane, that is perpendicular to the plane. So, generally angular displacement is always along the axis of rotation. The particle is carrying out circular motion about this axis, rotational motion you can call. About this axis, the axis shows the direction of angular displacement. So, these are the factors that you have to know. Now, I am going to the next term, that is angular velocity. How you define linear velocity? Linear velocity, or I will write only velocity. Velocity is displacement upon time. So, linear velocity is linear displacement upon time. I am talking about this type of displacement. If I add word angular here, I have to add word angular here also. So, how you are going to define angular velocity? Angular velocity is the rate of change of angular displacement with time. Whenever we take ratio with respect to time, it is called as rate. When you take ratio with respect to distance, it is called as gradient. So, we are talking about rate at which this radius vector rotates, that is what is called as angular velocity. For angular velocity, the notation used is omega. Bar indicates it's a vector quantity. Now, if I want instantaneous angular velocity, instantaneous means what? Where the time interval is very short, tending to 0. In maths, you have studied about taking limit as something tends to 0. It is a very small quantity, but not equal to 0. So, instantaneous angular velocity will be limit delta t tending to 0 delta theta bar upon delta t. In derivative form, how you write this? It is d theta bar upon dt. This is instantaneous. I am writing INST, which is indicating instantaneous, means at that moment. If I want to know what is omega bar, which is average, it is not instantaneous, it is not at that time. If I want to find average velocity, angular velocity, then I will have to write theta 2 bar minus theta 1 bar upon t. So, this is change in angular displacement upon time. So, this will give me average angular velocity in time interval t, which is not tending to 0. So, these two are different things. What will be unit of angular velocity? SI unit of angular velocity, check what you are getting. What is SI unit of angular displacement? It is radian per. What is SI unit of time? Second. So, what are going to be dimensions of omega bar? That is angular velocity. Radian does not have any dimension, as we have seen here. I will explain why again. So, only this second time, that will, if you bring it to the numerator, it is m0 L0 t raised to minus 1. The time is here in the denominator. If you bring it to the numerator, then it will be raised to minus 1. Now, do you remember any other quantity which has the same dimensions? I am not talking about same unit, I am talking about same dimensions. So, I am writing here, remember this, same as frequency. So, frequency and angular velocity have the same dimensions, although they don't have the same unit. Now, this is because angle does not have any unit, any dimensions. Now, I am writing definition of angle. This is the fundamental definition which you must remember for the further derivations. Angle in previous standards, say 7th, 8th, 9th, somewhere, you have defined basic angle. It is not defined as intersection of two rays, etc. I want mathematical definition of angle. Then angle is defined as length of arc upon radius. What will be unit of length of arc? Length of arc, SI unit is meter. What will be SI unit of radius? Meter. That is why we say, even though angle is measured in radian, it does not have any dimensions. So, angular velocity, again I will write in a similar manner, omega bar, that is angular velocity. SI unit I have already written, dimensions I have already written. I am just writing the type. What type of quantity it is? It is a vector. What will be its direction? In the direction of delta theta bar, that is angular displacement. So, angular velocity and angular displacement will have the same direction. In diagrammatic form, you can show if the particle is moving anti-clockwise, then delta theta bar and omega bar will have the same direction. Now, next term that we have to know, angular acceleration. How you define acceleration? Equal to change in velocity upon time. So, with the analogy of linear motion, if I want to define angular acceleration, this is linear acceleration, change in velocity upon time. If I want to find angular acceleration, then just add the word angular here. Means angular acceleration can be defined as rate of change of angular velocity. This is denoted by letter alpha bar. Again same way, if I want to define it instantaneous angular acceleration, then it is going to be limit delta t tending to 0 delta omega bar upon delta t, or this can be written as d omega bar upon dt. This is instantaneous angular acceleration. If I want to find out angular acceleration denoted by letter alpha average, then I will have to write omega 2 bar minus omega 1 bar upon t. This is similar to this. The first one is similar to this. Now, from this formula, can we get what is the SI unit of angular acceleration? SI unit of alpha or angular acceleration is radian per second is SI unit of angular velocity. Second is SI unit of time. You will get the answer as radian per second square. Obviously, dimensions of alpha bar equal to radian dimensions m0, L0, T0. If this is taken to the numerator, it is going to be minus 2. So, these are the dimensions of angular acceleration. Let us move a little further. Now, what type of quantity it is? All of you must have already understood that it is a vector, because I have drawn a bar on top of the notation used for angular acceleration. So, it is a vector quantity. What will be the direction? See, omega bar. If this is the direction, anti-clockwise direction in which the particle is moving, then we have seen there that angular velocity will have a direction along the axis of rotation in the upward direction. Now, what will be angular acceleration direction? There are two possibilities. Imagine a situation when you switch on a fan. Does it start moving with full speed at once? The moment you switch it on, is it going to rotate at the maximum speed? No. It slowly increases its speed to the desired value. This is because of the inertia that the fan possesses. So, in such a case, the angular velocity of fan is increasing. So, here I am writing vector if omega bar increases, like switching on a fan. If angular velocity increases, alpha bar will be in the direction of omega bar. Or if you want, I will write it more clearly. I will consider two cases. and then you will understand the direction of angular acceleration. This is omega bar. If angular velocity increases, means what? Final velocity is greater than initial velocity. Then alpha bar is in the direction of omega bar. Consider a situation. So, here I can draw alpha bar in the direction of omega bar. Second situation, anticlockwise sense only, this is omega bar, but now assume that you are switching off the fan. Does it come to rest immediately? Take example of your vehicle, you apply brakes, it does not stop instantaneously, it covers certain distance, its speed goes on decreasing and then it comes to a halt. It is because of the inertia of the body. Same way, when you switch off the fan, due to the rotational inertia, the fan slows down and comes to a halt after certain time. In such a case, what I will have to write here, if omega bar decreases, this is the opposite case, final velocity is less than initial velocity. This you can imagine, fan is rotating fast, you switch it off, it slows down, comes to rest. In such a case, alpha bar is in the direction opposite to omega bar. Why this is there? If you take omega 2 bar minus omega 1 bar, it is going to be less than 0, means it is going to be negative. In this case, omega 2 minus omega 1 is going to be greater than 0 in first case. So, here the angular acceleration alpha bar is in the direction opposite, that is, it will be downwards. Remember these two cases, these are the basic things which we will have to understand for our further discussion. Now, there are few terms remaining like uniform circular motion, periodic time, frequency of rotation, what is the relation between omega and frequency, angular velocity and frequency, that we can continue in the next lecture. And then I will start with the derivation part. There are certain things like centripetal force, centrifugal force, those you have to understand, their meaning, their physical significance, where they occur, and then go to the derivation. There are 4 or 5 long derivations in this chapter. Every year one of the derivations comes in the board exam. So, we will continue that in the next lecture. Thank you.